We're going to now write the easiest of all the power series. We're just going to let all the coefficients, all the c's, be 1. And here's the series we get. This is the sum, as n goes from 0 to infinity, of x to the nth. So that's x to the 0 plus x to the first plus x to the second plus x to the third, dot, dot, dot. You can see what I have here. So agree that to get from one term to the next, we always multiply by the same value. We're going to multiply by x. So this is a geometric series with r equal to x, and with a, the first term, equal to 1. So a geometric series will converge as long as r is between -1 and +1. And it will converge every time to this value, a divided by 1 minus r, which you have to memorize. So this power series, 1 plus x squared plus x cubed plus dot, 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 is equal to 1 over 1 minus x, which is pretty amazing. We have a bunch of polynomials, x to the first, x to the second, x to the third, x to the fourth, and if we add up infinitely many of them, we get a function that isn't even a polynomial. 1 over 1 minus x is not even a polynomial. So this is a pretty big step to start with, because what we're going to look for is polynomial functions that we can add together, so power series, that we can use to approximate more complicated functions. Now, why do we get so excited about polynomials? Because polynomials are smooth and continuous, and they're easy to compute, and they're easy to graph, and they're easy to perform calculus on. So that's what we're going to start with. Now, we have like our favorite power series is this one. 1 plus x squared plus x cubed plus x to the fourth plus dot, dot, dot. And we know that it's equal to 1 over 1 minus x. Now, I've got this big caveat over here hanging over my head, which is that's only true if x is in between -1 and +1. So I'm just going to promise you I'm not going to mess with that. X will be between -1 and +1, and we're going to work more in the later sections about how to decide what that interval is and how to prove that we're not accidentally stepping outside that interval. Okay, so the cool thing is, with just a teeny tiny bit of algebra, we can take this one fact that we know, we sound pretty smart because we have this one big fact, right? And we can actually, the word we use, we're going to transform this power series to approximate other functions that we might be interested in. So that's what this next example is all about. Okay, so let's try this first example. I know that 1 plus x squared plus x cubed plus dot, dot, dot equals 1 over 1 minus x. So for example 3, I've been asked to think of a power series. So something sort of that form of that series, coefficient times the power of x, coefficient times the power of x, that will equal 1 over 1 plus x. So here's the process you have to go through in your mind. I'm going to compare this 1 over 1 plus x to the sum of an infinite geometric series formula, and I'm going to ask myself, well, I can tell already that 1 is standing in for a, that's good. I'm going to ask myself, what would I let x be so that when I do, what would I let r be so that when I do this formula, a over 1 minus r, I get 1 over 1 plus x. So here, if I replaced r with negative x, I would have a over 1 minus negative x. I would have minus a negative x, that would cancel. So that's what I'm going to do. To get an infinite geometric series, a power series, that's equivalent to 1 over 1 plus x, I'm going to make a power series where r is negative x. So the first term is going to be 1. You can see that it's written out here already, but I'm going to just show you that process that my thought process here would be. I'm going to make the first term 1, and I'm saying that r is going to equal negative x. That means I'm supposed to multiply by negative x to get the next term. So my next term is going to be plus 1 times negative x, plus, I'm going to multiply by negative x to get the next term. That's going to be negative x squared. And I can see the pattern. You can see they've written it here for you. I just want to mention something as we go. Most of the time on the AP test, to get full credit, they'll ask you to do something like write the first 3 terms and the general term. The general term means a term that has like an n in it so that you could plug in any n you cared about to get the nth term. So what we want to write is some formula for a term that I could plug in 100 to get the 100th term. So if I understand what's going on here, this is like negative x to the 0, negative x to the first, negative x to the second, negative x to the third. This is just negative x raised to the nth power. So that is what I would call this the general term. That's negative x raised to the nth power. If I wanted the first term, I would plug in 1 for n. Oops, that's really n minus 1, huh? So the first term is really n x to the 0, negative x to the 0. So my term is actually 1 less than, the power I want to use is actually 1 less than the term number. So I would say that negative x to the n minus 1 is my general term. So now if you believe our answer to part A, that 1 over 1 plus x is equal to 1 minus x plus x squared minus x cubed plus x to the 4th, then watch what we can do to get an answer for this. If I want to find a series that's equivalent to x over 1 plus x, compare that to a series I already know. I already know a series for 1 over 1 plus x. What would I do to 1 over 1 plus x to turn it into x over 1 plus x? Well, I'd take this whole thing and I'd multiply it by x. So that's what I'm going to do on the right-hand side of my equation too. I'm going to take that whole series, I'm going to multiply by x. So for my answer for part A was 1 minus x plus x squared minus x cubed. My answer for here is going to be every one of those terms multiplied by an extra x. So 1 times x makes x. Negative x times x makes negative x squared. X squared times x, x cubed. Negative x cubed times x, negative x to the 4th. And here I could continue on and write the general term. That's x to the first minus x to the second plus x to the third. So that would be the opposite of negative x to the nth. So because when I have the first term, that's x to the first power, but it's positive. So if I have this negative here, is going to make, excuse me, is going to make the terms alternate in sign. And this negative here is just going to switch it so that the odd terms are positive instead of the even terms.